Hello, students. Today we are going to discuss circular motion. In particular, we are going to discuss uniform circular motion. Uniform circular motion. So first of all, let me draw a representation of the situation. I'm going to draw a large circle here, showing the circular path. And I'll have to emphasize that there is a table here. So that means I'm observing this front view. And I can put my object here that is orbiting the circular path. That's the mass there. And that's the center. This provides the tension force. Going to put an arrow here, That will provide the tension. This is the direction of travel of the mass. We can put this arrow to indicate the tangential velocity of the object. If the object is at a different position, like here, still is a cube. If the object is here, it will have the tension like that. Okay, and then the velocity at that point will be right there. So here's velocity at this point, and then velocity, let's say another velocity there. Okay, velocity 1 or velocity 2. All right, so at this time we can see that the object in circular motion has covered this amount of rotation here, which we can call theta. It's like the amount of rotation. The object has mass m. Our focus is on the kinematics, is on how the object is moving in this lesson. So we're just going to focus on two kinds of speeds that we can talk about. The first one is linear speed. And then the second type of speed is rotational speed. Rotational speed. All right. So we are going to start by looking at linear speed. Linear speed, which is also called tangential speed, is given by this formula. Linear speed. Linear speed is equal to distance divided by time. In formula form, you can use V equal to change in distance divided by change in time. For example, we can have a problem like this. Assume that the radius of a circular path, if the radius of a circular path is 50 centimeters and the object completes an object completes 1 revolution, maybe in 2 seconds. Determine the linear speed. So we want to determine the linear speed of the object. We can go ahead and say V equal to change in distance over change in time. Now we are told that it completes 1 revolution. So the distance we are talking about is the distance around the circular path, which is the circumference of the circle. That will be 2 pi r. Remember, circumference of a circle is 2 pi r. You divide by the change in time. There you plug in 2 times pi times the distance around, the radius. Radius is 50 centimeters. Let's convert that to meters. So our velocity will be meters per second. 50 centimeters into meters is 0.5 meters. divide by time is 2 seconds. If you do this, you'll be able to find your velocity as 1.57 meters per second. Sorry. 1.57 meters per second. So that means the object covers 1.57 meters every second as it is orbiting around the circular path. We can have also other units for linear speed, like centimeters per second, kilometers per hour. You know, this is just like the usual speed, you know. So different units can be used. All right, let's move on to the other kind of speed, which we call rotational speed. Rotational speed is defined as the amount of rotation divided per unit time. So this is actually amount of rotation per unit time, right? The amount of rotation can be in different units, and the time also can be in different units. We are going to see different ways of talking about rotational speed, or different units for rotational speed. Well, this is just a definition. In terms of a formula, we might want to write this as wish we had a formula for rotational speed, but let's not use the formula for now, but yes, just write it as this rotational speed. Rotational speed, which is also called angular speed, is equal to amount of 10, amount of rotation, or amount of 10. Then I'll put a slash here, time taken to complete or to do that 10, time taken. Now here is our example. Our example is as follows. If an object completes 2 revolutions in 4 seconds, if an object completes 2 revolutions, don't have enough space there. This should be revolutions. 2 revolutions in 4 seconds. What is the rotational speed? So what is its rotational speed? Well, the question does not specify the units of rotational speed. So what we are going to do is to find the rotational speed in different units. So we are going to find the rotational speed in different units so that you can appreciate the various units that are used when you talk about rotational speed. Now, recall the formula says that rotational speed is equal to amount of 10, amount of rotation or amount of 10 divided by time. So for this problem, amount of 10 is 2 revolutions. So you can just have 2 revolutions, and then you divide by time, which is 4 seconds. 4 seconds. That will give you 0.5 revolutions per second. Okay, so that's the answer. You might want to convert to different units, which is usually the case when you talk about rotational speed. So let's convert this to revolutions per minute, which is a very common unit. So let's say convert 0.5 revolutions per second into, let's say, into what? Into revolutions per minute. Revolutions per minute, also known as RPM. All right, RPM stands for revolutions per minute. So I'm going to write 0. One thing before we do this conversion, we have to realize that a good conversion here, very important conversion, is that 1 minute is equal to 60 seconds. 1 minute is equal to 60 seconds. So therefore, we can write 0.5 revolutions per second is equal to 0.5 revolutions per 1 second. Then we are going to multiply by 60 seconds, divide by 1 minute, because we know that this is actually equal to 1, because 1 minute is equal to 60 seconds. Therefore, 60 seconds divided by 1 minute is equal to 1. So we are not changing anything to this quantity here. We are just multiplying it by 1. So multiply 60 seconds divided by 1 minute. And the hope is that the seconds here will cancel with the seconds here, and you remain with revolutions per minute. So when you do this, you end up with 30 revolutions per minute. 30 revolutions per minute. Now we call this one, sometimes we just write this as 30 RPM, 30 revolutions per minute. All right, so let's try to convert the same quantity into now radians per second, which is also common. So convert 0.5 revolutions per second into radians per second. Radians per second. Now to do that, you will actually convert 0.5 revolutions per second into radians per second. To do that, you're going to realize one thing about the connection between radians and revolutions. So it is well known that 1 revolution is equal to 2 pi radians, right? 1 revolution is equal to 2 pi radians. So you can write this quantity, 0.5 revolutions per 1 second. This must be equal to what? Must be equal to 0.5 revolutions divided by 1 second. Now I have to multiply it by a factor. That factor should enable me to have my answer as radians per second. So because of this conversion here, I can safely say that multiplying by 2 pi radians divided by 1 revolution does nothing to this factor, because this actually, from the conversion here, 2 pi radians divided by 1 revolution is just 1. So this is the 1. So when I do this, I'm doing nothing to the initial quantity. I'm just multiplying by 1. Multiplication by 1 does not change the number. So because of this conversion, I'm very sure that revolutions here will cancel with revolutions here. Then I'll end up with 0.5 times 2 pi radians. That will give me actually 3.14. The units on top now will be radians, because we no longer have revolutions, radians, and then down there we have seconds. So that's the rate the rotational rate for this case, 3.14 radians per second. Okay, so let's look at the connection between linear speed and rotational speed. Linear speed and rotational speed, how are they related? And rotational speed. These are related. Linear speed is related to rotational speed as follows. So linear speed is equal to radial distance and then times rotational speed. Rotational speed. The units for linear speed is just this one becomes V. We use V and then equal to the units for radial distance, we use R, then times rotational speed, the units will be omega. So V is equal to R omega. It's how linear speed is related to rotational speed. The omega here, this is called omega. This is looks like W, but it's omega. It's a Greek letter standing for rotational speed. And to make sure that for this to work, this must be in meters per second. The radius must be in meters, and the omega must be in radians per second. The amount of turn must be in radians, and then the time to be in seconds. So radians per second. So this formula is true when the units of linear speed are in meters per second, the units of R are in meters, and omega is radians per second. So the implication is that you move faster when you are far from the axis of rotation, and also you have a larger, if you have a larger rotational speed, then your linear speed increases. That's what it means. Linear speed depends on how far you are from the axis of rotation and how fast in terms of rotational speed you are spinning. You can see that there's a good connection between linear speed and rotational speed. Let's look at a problem on merry-go-round. On merry-go-round, you move faster. You move faster in meters per second when you sit away and rotate faster, right? That's what we know. And that's why V is equal to R times omega. On a merry-go-round, you move faster in meters per second, that's linear speed. When you sit away, R is larger and rotate faster, omega. So using this, what's your linear speed? What is your linear speed? If your angular speed, which is also called rotational speed, remember angular speed is also called rotational speed, is 3.14 radians per second. And okay, so yeah, and we have to look at the distance also. And R is, and you are sitting at a distance from the center, and the R happens to be 50 centimeters. So what is your linear speed? So we are going to apply the formula V equal to R omega, and make sure that when you use this formula, radius is in meters, 0.50 meters, multiplied by omega, 3.14 radians per second. When you do that, you're going to find your velocity will be actually 1.57 meters per second. 1.57 meters per second. All right, so we have learned the two kinds of speeds, linear speed and rotational speed. We have seen the different units for each one of them, and we have seen the connection between linear speed and rotational speed. I'll stop here for now. If you have any questions, please let me know. Bye for now.